Hello everyone, my name is Nilza Chodan and I belong to the customer technical support team here at Seabird Scientific. I've been working with Seabird for nearly a year and a half, and today I'm going to be talking about our CTD operations and data processing, especially for our profiling system. In this particular presentation, I'll be talking very specifically about our profiling system, such as SBE 19+V2. Today, I'm going to be talking about the difference between the profiling versus moored system, introducing what the 19+V2 system looks like, its physical overview, the plumbing system, the difference between vertical and horizontal orientation during deployment, and how to configure the 19+V2 with CTERM version 2. What is profiling versus moored system? In a profiling system, this is where we measure oceanographic parameters such as temperature, salinity, oxygen, etc. with respect to depth. On the right side, this is where we're measuring oceanographic parameters by lowering the CTD in the water. So when the CTD is lowered, this is called a downcast. And when the CTD moves up through the water system or is pulled up, that's called an upcast. In a moored system, this is where the instruments are held stationary to a platform. In this case, the instruments here are connected to a buoy, and this is where the samples are measured with respect to time. Next, I'll be talking to you about how the 19+ system works and its overview. So here I'm going to present to you what the SBE 19 looks like. I'm going to start from here up top. This is where the internal battery pack goes in. We use alkaline D-cell batteries. And here we have the communication section of the 19+V2. That's where all the connectors are plugged in. The water goes in through here, which is the water intake. This is the guard cell, and underneath the guard cell, you have temperature probe, conductivity probe. The conductivity cell is then connected through all the Tygon tubing to the SBE 43 dissolved oxygen sensor. The pump over here pulls all the water in to the system, and the Y fitting connects the whole system in this area, and we have the air bleed, which is super important for the bubbles to be released from the SBE 19+. Here I have what is called a magnetic switch, which is turned on or off depending on how you set up your SBE 19+ system. It is important to note that the magnetic switch only collects the data. And now let's see how the water flows into the SBE 19 system. It's important to make sure that the pump is on and it's pulling water and rather not pushing it. Let's go through the diagram step by step. The first step is where the water is goes through the intake system here at the conductivity guard cell. So the outermost layer would be the guard cell, and inside the guard cell we have the temperature probe first, and then we have the conductivity cell. So the water goes through the system into the Y fitting and this Tygon tube, and then it flows through the pump and out to the exhaust. It is important to note to not run the pump dry for more than a second or two. It's also important to note that the water is being pumped constantly, because if that's not done, there are issues with the data, and you can have drift in temperature conductivity, and include if you have other auxiliary sensors such as dissolved oxygen, you'll get issues with that data. Now we're going to talk about the difference between vertical and horizontal orientation during deployment. Through this system, we'll be talking very specifically about the difference between the plumbing of the 19 plus V2 in these two different types of orientation. Let's start with vertical plumbing. Now that we've been through a lot of physical overview of the SBE 19 plus V2, I'll be talking very specifically about the vertical orientation deployment in this system, and very specifically about how the plumbing fits. Right here, you have the conductivity cell, the Tygon tubing, and the Y fitting. It's important to note how it's in, and the air bleed is basically at one of the highest point of the instrument. And that's important because that's where all the bubbles are released from the whole system. And it's important for us to get rid of the bubbles so that we get high quality data during vertical deployment of SBE 19 plus V2. And now I'm going to talk about the horizontal orientation, and very specifically the plumbing part of it. On the right side, you have the SBE 19 plus V2 oriented horizontally. Please note that in this system, you have the SBE 43 in between the conductivity cell outlet and the pump inlet. In this orientation, it is important that the pump exhaust is pointing upward or towards the surface. Between the horizontal and vertical orientation, take a look at how the Tygon tubing is fitted in this particular section. It's like an S or S-shaped, and let's take a closer look at it. So it's important to have the Tygon tubing placed this way, like a staircase or an S shape, is because it is important for the bubbles to escape through the exhaust. Because if the bubbles stay in the system, you'll have errors in the data. Next, I'm going to tell you how the SBE 19 plus V2 is configured with C-term V2. So C-term V2 or C-term version 2 is one of Seabird's software that allows you to configure the 19 plus V2 system. It's a terminal based software where you have options for menu for how to connect, disconnect, send commands, create a capture file, which I'll be talking about in a little bit, how you upload the data, and send commands to configure the instrument. And now we'll be connecting the instrument, the 19 plus V2 to CTERM V2.
Here I have the CTERM 19 plus V2 connected to CTERM, and I'm uploading the data here. Once you start uploading the data, you get the status-based command output automatically, such as dsdc get hd. And I click upload, and a new window pops up, and I start my upload data process. You basically find the correct place to upload your data. You can in text or binary, and now you start uploading your data in your computer. If you note on the left side in the corner, it's how it basically tells you how your data, what type of files are being uploaded in your system. So here we'll see how the data is uploading.
Now that we have connected the SBE 19 plus V2 to our CTERM V2, we'll configure the 19 plus for profiling mode. It's important for you to enable all the auxiliary sensors you have connected to the 19 plus V2. Make sure that the pump is on. And you can do that by ensuring that the minimum conductivity frequency is of the right value. So if you're deploying the instrument in salt water, it will be your zero conductivity frequency, which you can find it in your calibration files, plus 500 hertz. And in fresh water, you will add 50 to the zero conductivity frequency. And furthermore, you will perform these particular setups, such as the pump delay, or when you want to start the instrument to start sampling, when to stop. An important note I will make is very specific to the magnetic switch that we just covered in the physical overview. Switching that on and off basically means you collect data, which is on, and off means you to not collect data. This table gives a really good depiction of how to use those particular commands with the magnetic switch on and off. So for instance, if your ignore switch command is a no, your auto run command is a no as well, then to start logging, you will slide the magnetic switch on, and to stop logging, you will slide the magnetic switch off. you can keep doing or perform these 3 configurations to collect data in the profiling mode. Additionally, it's important for you to make sure that the auxiliary sensors that has been enabled in CTerm is also enabled in your XML conf file. This will be further covered by Dane in the next presentation. Here, I will be presenting or showcasing what a vertical deployment would look like. So in the plumbing, slide, we did talk about how the water flows through the entire system. So let's imagine that the 19 plus system is in vertical configuration. We're going to put this in a tank for a test deployment. And the water goes through the water intake. It goes through the conductivity temperature probe. The water then flows to the air bleed and Y fitting. And this is where you will start observing bubbles coming out of the air bleed. It is important that you soak the instrument at least 5 to 7 minutes, or the instrument needs to be completely submerged in the water for the bubbles to come out. When you see the bubbles not being formed anymore, you can start lowering the instrument for your profile. If you're at sea and there's sort of wave actions at the surface of the water, you could lower the instrument down to let's say about 4 to 5 meters or below the mix layer until the bubbles come out for 5 to 7 minutes, or sometimes 10 minutes is even safer, depending on how deep your deployment is going to be. And then when that's done, you can start lowering the instrument down for your profile. So when all the bubbles are released from the instrument, the water then flows through the SBE 5 pump, and then the water gets out of the 19 plus V2 from the pump exhaust. So what were the takeaways from this particular demonstration and the entire presentation so far? So it's important to note that your pump is always on and it's pulling in water and not pushing it. It's secondly, to never run the pump in air. When you set up or when you configure the 19 plus V2 system on CTerm, make sure that all your auxiliary sensors are enabled or disabled accordingly. And make sure it's in profiling mode, and we go through and make sure that the minimum conductivity frequency values are correct and are there as per your settings. It's important to also note that the plumbing is set up according to the deployment. For instance, here I did deploy the instrument in vertical orientation, so my Y bleed, Y fitting and air bleed is at the highest point, so that all the bubbles come out of the instrument, and then start deploying. Submerge the instrument in the water for 5 to 7 minutes until all the bubbles come out, and so basically, correct plumbing as per the orientation you want to deploy the instrument in, and submerging the instrument for 5 to 7 or 10 minutes as per where you are deploying the instrument, and allowing the bubbles to escape will get you a high quality data. After you have collected the data, you will upload the data in CTerm v2, which I demonstrated earlier. And through that, we'll have data in raw data format of your choice, for example, hex data format. And we'll be able to process that in SBE Data Processing software, which will be further elaborated in Dane's presentation. Thank you.
Hey there, my name's Dane Lucas, and I'm with Seabird Scientific, and today I will be talking to you about how we can use SBE Data Processing to convert your raw instrument data into engineering units and then later visualize it via cplot, our processing and plotting application. So let's go ahead and take a look at the agenda. First, we're going to start with actually setting up an XML file and getting to be a bit more familiar with what those are. Then we'll talk about the actual data conversion aspect and how to configure it the way that we want for our data. And then lastly, we'll go ahead and look at charting with cplot to make sure we can actually visualize our data in an interesting way. So first, let's talk about setting up an XML file and what they actually entail. So an XML file is the file that you're going to use to input into the conversion software to make sure that the software knows specifically what external sensors and what calibration coefficients we have for our instrument. And it's important that we make sure we get this right, otherwise our data might be a bit off, or we might not even get any data for some of those external voltage sensors if we don't specify them via an XML file. So to get started, we can go ahead and open up SBE Data Processing and navigate over to the Configure menu and open that drop-down to select the SBE 19 Plus V2. This is the instrument that we're going to be using, so let's go ahead and keep all of our attention on that. And that'll open up this menu here, which allows us to set some of these configuration options for the 19 Plus V2. Now, you can start from scratch like I have open here, or you can go ahead and click the Open button here, and that'll allow you to select an existing file to start with. So that's really useful if you have just a few minor changes that you need to make to your XML file. But if you have a lot more to do, then maybe it's better to start from scratch, or to, just make sure you're actually applying those to your instrument file that you've opened. So in this example, I've got 4 external voltage channels that I'd like to fill out, but none of them are filled out yet. So we can go ahead and right-click the first free section, and this is for AD voltage 0, and we can go ahead and make sure that we select the correct instrument for this voltage sensor from this drop-down. So in this case, I've got a fluorometer, and let's make sure that we choose the correct one, of course. But I can go ahead and select that, and then make sure I put in the correct values for the serial number, calibration date, dark output, and scale factor. And different of these sensors are going to have their own calibration coefficients that you have to keep in mind, but it's important you put the correct calibration coefficients in, because that's what allows you to properly make sure you get the best data out of those sensors when you get to data conversion. So after we've gone ahead and done that, we can see it show up in the list here, and then we just need to go ahead and make sure we fill out the other 3 of these AD voltage channels that we're currently using for our instrument. So go ahead and do that, and then we can see all of them listed here. These are the ones that I've got attached to this 19 Plus. And we can go ahead and hit the Save As button to make sure that we're saving it out under a new file name. Unless we're really interested in overwriting our existing file, it's usually a good idea to save it out as a new file, because that way we know that the old set configurations are still there, just in case we'll need to use it down the line to, potentially reprocess some old data that we've taken under that previous configuration. Now, this is going to be our input file going into SBE Data Processing, and specifically into the conversion module, along with the raw data that we got doing our data upload. So let's start talking about that now. So you've got your raw data, you've got your XML file, but what do you do now? And this is where data conversion comes in, and this is where really the meat of it all happens. So this converts your raw data from your instrument into a number of these different primary quantities like pressure, pressure, temperature, and conductivity data, as well as your auxiliary sensor data based off of whatever you've plugged in. For example, we had the fluorometer plugged in, so that can give us some interesting data that we might want to convert as well. Then, after we've done data conversion, we can go ahead and take that output file and plug it into cplot, where we can actually go ahead and plot the data and visualize it in a number of different ways, but we can talk about that a bit more later. Another option is, after completing data conversion, you can go ahead and stick that into some of our advanced data processing sections. But we're not going to be talking about that today because they go a bit over the scope of what we're going to be needing to talk about. But it's important to take a look at them and see what they can do for you, because they can be used to apply a number of different corrections to your data. So I'd highly recommend checking those out at a later date. So let's get started with the actual data conversion itself. So like I said, this is all for going ahead and converting raw data into engineering units. And we're going to focus mostly on the primary quantities here, so temperature, conductivity, and pressure. You can also compute some parametric quantities here if you are so interested. For example, salinity is a really common one that everyone likes to convert. And the reason we say may is because if you are planning on going ahead and using any of the advanced data processing modules after doing a data conversion, then you're going to want to hold off on computing those parametric quantities, because you'd rather do that after doing all of the other data processing modules. But today, we're just going to be starting with conversion and just doing conversion. So if we wanted to compute salinity, for example, then plot it, then we totally could. So let's talk about the file setup. We're going to want to make sure that we select the correct instrument configuration file. This is the XML file that we just created a few minutes ago. And we'll also want to make sure that we select the correct hex file that has the data from our instrument. So we've just selected the one. You can select multiple here if you have multiple files that you all want to process using the same configuration, but we've just got the one right now. Down in this bottom section, you can select where you want the output to go out. It's going to default to the same location that you have your input files, but you can select somewhere else if you so choose. And you can choose to append something to the end of the file name. And you can also completely overwrite the file name to something else if you wanted, but we're just going to leave it at the defaults for now. Navigating onwards to the data setup tab, this is where the real magic happens, where we can really specify what we want going into our output file. So the most important section here, in my opinion, is the select output variables, where we can actually pop open this window, and this will allow us to go ahead and select which variables we want in our output file and in what order we want them to show up in. So I've chosen to select temperature, pressure, conductivity, and time elapsed in seconds for my output file. But as you can see on the right, there's a number of different sections that you can potentially add to your data, and in a number of different units as well. If you're looking for something slightly different, you have the ability to. You could even select the same variable with multiple different units for it. For example, you could have temperature in degrees C, but you could also have temperature in degrees F if you just want to visualize one or the other, and that's something that works for you. Now, coming back over to this data setup tab that we were looking at before, there's a few other sections in here that could be interesting to look at depending on your what you're looking to do. For example, you can choose to convert data just from the upcast or just from the downcast. If you know that one of the two is maybe untrustworthy, or if you're not too interested in one of them, then you can just stick with one side of it. You can also go ahead and choose to, skip some of the scans at the very beginning of the file. If you know, for example, that your instrument was just lying sampling on the deck for 200 scans or so, you might not be so interested in that data. So you can go ahead and skip right over those. You don't have to worry about dealing with it later. There's a number of different other options here I'd recommend looking at as well. But for now, let's go ahead and tab over to this miscellaneous tab. And in here, there's a few different options which may or may not be relevant to you depending on what you're planning on getting out of your data. So we have sections here, for example, average sound velocity. If you are planning on outputting average sound velocity as one of your variables from the previous section, then you want to make sure that you actually fill out all these values here, because they're going to be very relevant to what that data looks like for you. If you aren't planning on outputting any of these variables as a part of your conversion, like for example, we're not currently, we don't actually have to worry too much about this tab, because these values aren't going to be used for anything other than the variables that they list specifically there. So now that we've gone and done that, we can go ahead and make sure we actually run the process, and that'll create our output file in the location that we specified. And now I've gone ahead and opened that up here, and we can go ahead and take a look at what it looks like and what sorts of things you can expect from it, and how we can use it. So opening this one up, there's a number of different fields in here. It has a lot of instrument metadata, which is interesting to look at and might be valuable to look at down the line. But you also have possibly one of the more interesting sections is down here near the bottom. You have all of the different variable names in the order that we specified before, as well as the min and max values for each one of them. So this can give you a really quick overview of sort of what your data looks like. And it can also be helpful for actually planning what these values are. This is also all the converted instrument data, so we can go ahead and take a look farther down in the file itself, and we can see scan by scan, this is what our data is. There's no reason necessarily to go in here and look at all this data manually, because that's what our different modules are for. But you have the ability to, if you're just sort of interested in seeing what the contents of the file are. But now that we have that file, we can go ahead and take it on over to our plotting using cplot to actually visualize our data. So let's go ahead and talk about first, what is cplot and what can it do for us? So cplot's another one of the different modules that we have within SBE Data Processing. So if you'll go ahead and open the Run tab here and navigate to the bottom, you'll see cplot. You can open it there very easily. Cplot can be used to plot 1 to 4 parameters against a single y-axis. You can also plot 1 to 4 parameters against a single x-axis if that's something you prefer. That's particularly useful for time series data. So if that's something you wanted to do, it's a great option. You can select the different axis values interactively, and it's included with the SBE Data Processing software, so you don't have to worry about opening up some different other software when you want to get started with this. So just some example data sets of things we can sort of expect to get out of this. These are simple temperature and salinity versus pressure graphs. So we can go ahead and take a look at what those look like with the upcast and the downcast, those useful data. You can continue onwards and look at some more complicated data sets where you have fluorescence, temperature, salinity, and beam attenuation all plotted against pressure. So as I mentioned, you can have up to 4 of these different parameters plotted against a single y-axis like we're doing here, and it can be useful for getting a really quick view of what your entire data set looks like. So let's go ahead and talk about how we can actually set up a chart that looks like this. So first thing to do is to open up that cplot module like I mentioned and set up the actual files to make sure that we're selecting the correct ones. So our input file is the CNV file that we created as an output from the data conversion module. And we can go ahead and make sure that all these other settings are just fine. Now, there's nothing much that we have to change in here, but perhaps if you want to save out the chart somewhere, you might want to select information about like what you want to append to that file name or anything of that nature. We can navigate over to the plot setup tab and we can set up the plot. I've chosen to use a single Y and multiple X axis plot in this case, but this dropdown has all kinds of different options for a number of different ways that you could set up the plot. We'll talk about a few more of those a bit later. So going over to the next few tabs, our Y-axis, we're going to select pressure. It's pretty common to plot against pressure because it gives you a good understanding of what your data looks like as your instrument navigates its way through the water column. So that's what we're going to stick with as well. But I noticed something when I was going through here and setting up this plot, that our variable range is from negative 0.109 decibars. That implies that that's our minimum value for pressure, and that's likely from when this instrument was sitting on the deck and not actually in the water. So we don't care too much about that data. So instead of using the auto range, like most of our other variables are going to be using, I've gone ahead and specified that the minimum should be at 0 decibars. And that way I don't have to actually worry about that information showing up in my chart. So it helps refine the chart to be a little bit more concise. We can navigate over to the temperature in the x-axis 1 tab, and that's useful. We can go ahead and just leave all the other settings just as default for now. I have the ability to change the line color and the symbols and such if I wanted to. I didn't worry about it too much for this example, but you can configure the plot how you want, of course. And then we also can go over to x-axis 2. And when we are including more than one axis, it's important to make sure that you actually choose to include the axis. Otherwise, it might not show up, of course. So I've gone ahead and made sure to checkbox that. I have selected conductivity for this one, so we can plot that against the same axis as well. So going ahead and hitting the Start Process button near the bottom, we can go ahead and take a look, and here's our data. So We can still see that there is some interesting behavior near the very top of this, and that's likely still in the very top of the water column. There's something weird that was going on. But beyond that, we can see the downcast and the upcast of our data. And this is all the way from the raw data that we started with after doing a data upload earlier. So let's talk a little bit more about some of the advanced charting that we can do with cplot as well. So one really common use case that we get is TS plots. These are plots of temperature versus salinity, and they're great for visualizing how the density of seawater is changing. And you can use contours, and in this case we've chosen density as our contour using the TS plot setup button here to actually go ahead and visualize like how the density is changing over time. So we can go ahead and look at that, and we can open up this chart, which is a TS plot, as I mentioned, and we can see, wow, okay, this is pretty cool. You can see how the salinity is decreasing and the temperature is decreasing and the density is changing as well. It's a great, concise way to actually visualize your data, and there's a number of these different sort of options with cplot that you can use to actually visualize your data. With that, that's about all that I've got to cover for today, so we'll leave it open to any questions that you all might have, and thanks for your time.
All right, thanks, Dane and Nilza. If anyone has any questions, please go ahead and type them into the Q&A box, and our experts will get to them. Looks like we have one. Where can we find the temperature and conductivity sensors on SBE 19?
Hi, yeah, I think that's a question for me. It's right under the guard cell. I can pull up my presentation and show you where it is. Let's see. Yeah, just give me a second. Okay. So it's right here. It's like way it's you have to take off the guard cell to really see where your conductivity cell and temperature probe is located. Does that help?
You can go ahead and answer in the chat if you have any other questions. The next question we have from Diana is, hi, what about the other processing modules like filter, etc.?
That sounds like a good one for me to answer. Yeah, so I didn't get into them too much during this presentation because, well, there's a lot to each one of those modules, but they're all very valuable. And depending on your own data processing workflow and what corrections you might need to make, it's definitely worth looking into each of them to actually potentially run them on your data set. So the general workflow is what you would do is you'd take your CNV file from either the previous module, whether that's data conversion or something else, and then you'd run it through one of those modules, and then you can go and take a look at the newly processed data in cplot to sort of see how it affected your data. And the manual has good explanations. That's the SBE Data Processing manual, has good explanations of what each of the modules do and sort of recommended values for them. And I think we also have some previous content somewhere that sort of talks about how to actually use those manuals, but I'm not entirely sure where that might be living. It might be in one of the previous CBIRD University courses.
All right, and then the next question from Abigail, during surface soak, does the Y tube need to stay fully submerged, or is it okay if that breaks the surface as long as the intake and exhaust remain submerged?
Hi, so it's best to just completely submerge the unit because that's where you'll have the best chance to get all the bubbles out. And if you still have the Y tubing closer to the surface, you know, you can still get the air in the 19 plus V2. Please let me know if you have any follow-up questions.
All right, and then our next question is there a method to set up a batch file in the conversion process so it runs all the processes at once?
Yeah, there definitely is a way to do it. I'll be honest, I don't remember the exact specifics of how to do it. I know that you can set it up so that it uses either your current PSA files, which is the program setup file that gets created and saved out every time you run one of the modules. So you can have it go and use all of your PSA files, and you can specify which of the modules you want to run, as well as you can also specify different PSA files for each one to be able to actually run it as batch processing, which is very useful. Now, I believe that you might have to use a separate application. I believe it goes by the name SBE Batch to actually go ahead and do that. And the scripting that you have to do to actually set that up is a little bit tricky, but there's definitely a way to do it and can be very valuable if you're planning on running the same workflow on a large number of files, or just time and time again, you plan on using that workflow without any or very many changes. So that's a very valuable way to do it.
Then the next question, which is the best connection between temperature and conductivity plumbing on SBE 25 plus?
I quite don't understand this question. What do you mean by best connection between temperature and conductivity? I think I would like some elaboration on this particular question.
All right, we'll have them hopefully type something in the Q&A again to clarify, and we'll move on to the next one. For now, Francisco is asking, could you elaborate a little bit more on where to configure minimum conductivity value for turning the pump on?
You bet. So when you're setting up your 19 plus V2 connected to CTerm, you can use the command called minimum conductivity frequency. You can look that up in the manual as well. So the correct would be min cond frequency equals x, where x is the value. So I'm going to copy and paste this particular command in the chat, so it helps you there.
Nilza, do you want to put that in the answer for this Q&A? You can type it.
Yeah,
I think.
sure.
Maybe.
Let me do. Yeah, that's a good idea. Thank you.
If you go into that answer, you can click type answer.
Yeah.
And then
you can move on to the next question. I'll find that. Yeah. Thanks, Nicole.
Our next question is, how did they view the CSV file after using SBE data processing? My data ends up in the form of CNV.
Yeah, good question. So when I was looking at it, I actually did open a CNV file. So I didn't do any alterations to it to look at it. I just scrolled down in the file a bunch to actually see that data. But if you want to get a CSV file for your data, one of the data processing modules, if you go and look at that, if you open up SBE Data Processing and click on the Run tab, one of them, if you scroll down a ways, is ASCII out. Basically, what that one does is you can input your CNV file, which is the one that we created in data conversion, and then it'll output a CSV file that you can use. It might be a .ascii file, but it's essentially a CNV file. So that can be useful if that's what you're looking for any future processing or data manipulation that you're planning on doing.
And our next question, what is the best way to add any MEA data to hex files for processing if the setting to include them was not initially selected?
The best way to probably do that would be to go ahead and first you can select it in your XMLCon file configuration. So one of the options in there should be to actually choose to include NMEA data. And then I'm not sure what the best way to go ahead and make sure that actually gets included properly is. That's something that's always been a bit tricky to me. So there might be some documentations that we have for actually how to do that. Nils, I'm not sure if you have any knowledge on how to go about doing that.
That's a very good question. I think we can find some document to see how we can integrate the NEMA data. I think it also depends on how like the connection between NEMA data and the how the entire kind of setup is all together. But we'll look into it and send you more information. But please feel free to email us as well as a follow-up. We did really appreciate that.
Excellent. And then Abigail has this question. In the C-plot example, you showed a graph with the upcast and downcast looking very different. Is this a sign of a problem with the data? And what would cause this?
another good question. So it's possible that there's a problem with the data. It's hard to know without knowing the specifics of the setup and what might have happened on the cruise. It's possible, that the ship moved during the course of the cast if it was a very long one, such that you were simply in a different area of the ocean with different, I think it was the temperature was particularly what was differing between the upcast and the downcast in that one. So that's a possibility for it. But this is also a case where it's possible that there's some sort of weird drift going on, or there's some sort of other effect that's happening with the data that could be corrected via one of the advanced data processing modules. It's possible that some of the data is just misaligned, but it doesn't really look like that in this specific case. But I bet there's some ways that using the advanced data processing software, if you tinker around with it, that might be able to get corrected. But again, it's hard to know without knowing the specifics of it. So it's very difficult when you're looking at a data set to just say, oh yeah, of course, this is an issue that could be solved with a line CTD or something like that without actually trying it and sort of seeing like what the effects might be.
And then we have, how can we integrate a fluorometer and oxygen to an SBE 19 to be used in a horizontal system?
So we do have some application notes that you can look at, but are you being more specific about how to connect it through like hardware system and connecting all the wires, or are you talking about configuring XML conf file setup? So if you could please be more specific, would be really helpful. Thank you.
All right, let's see if we get a little more detail on that one, and we'll move on to, you said this SBE 19 Plus should be soaked for 5 to 7 minutes prior to collecting data. Is this for testing purposes only, or did you mean for standard casts as well?
I meant it for standard casts as well.
Perfect.
Thank you for the clarification question.
Adrienne is asking, I have 2 SBE 19 Plus V2s and want to compare the two to make sure that they have the same readings. What is the best way to compare them? I've done side-by-side casts, but the chlorophyll values are different.
Okay. So I think first I would check the calibration values are correct or not in each one of them. I would check if the cables are working. Maybe it is already because you're getting some data. But first thing is definitely to check how it's set up. If the setup is the same in both the fluorometer, I would start there.
Looks like a good start. Looks like we have some more information on the Y-tube submersion questions. Our sites are shallow. Just 4 meters or so. We drop the instrument to be fully submerged for a soak to debubble for a couple minutes, but then try to raise it close to the surface so we can begin the downcast as shallow as possible. We've been raising it such the exhaust stays below the surface, but wondering if we really need to keep the full Y-tube submerged.
Well, that's a really cool application, number one. I think with, it's what you have and what you have to work with. And here I would, when you're post-processing the data, you will see what the bubbles are coming out in the data. So you can eliminate it or keep the data and say, oh, this is where the bubbles are coming out. So that's some bad data included in your plot, and then just downcast it. But yeah, I like how you are profiling in this particular case.
All right. And then we have, how different is the CTD on the deep CFOX V2 versus that on the SBE 37 SM?
So I don't have too much familiarity with the CFOX V2 specifically, but my understanding is that when you're using it, you'll be connecting it to a 37 SM or SMP or SMP ODO to actually perform the CTD capabilities for the CFOX. So in that case, there shouldn't be any difference between them because it should be the same exact instrument.
Excellent. Emmanuel is asking, is there a method to set up a batch file in the conversion process so that it runs all processes at once?
Yeah, so this is something that I mentioned a little bit earlier, but I did actually go ahead and basically just Google SBE batch, and the first option that pops up is actually a training course from CBIRD that documents sort of like how to go about actually doing that advanced data processing with SBE batch to do that batch processing that you're talking about. So I'd go ahead and actually just start with that. And then you can poke around our website a little bit more to see if there's anything else that you need to get started with it. But that's where I would start because that was super useful for me for getting a quick understanding of it.
Excellent. Then our next question, how can we integrate a fluorometer and oxygen to an SBE 19? Oh, sorry, this is the one that we already covered. Could you re-explain how you were able to view the data in organized columns on Notepad after using SBE data processing?
Yeah. So in this case, what I did was I simply opened my CNV file in Notepad. In this case, you can use any text editor if you don't like Notepad for whatever reason. And then if you just scroll down into the down past all of the header information that you have, you should get to the bottom, and then it should just show line by line your data, and it should be in those organized columns. That should be what you're looking for, I think. If that's not the case, then it's possible something weird happened with your data processing, or it's possible that you should just go ahead and look in the ASCII out module that I referred to earlier, which is pretty useful for making sure you get that CNV file format, which a lot of people like to use.
All right, and then just in the interest of time, we might not get to all questions, but we'll do our best. So I'm going to skip ahead to, I have a 25p CTD and had issues with viewing my data with XML files. Do I have to modify my XLMCon file before plotting XML files? There's a question from Renee.
Okay. I would like to see something visual. So Renee, would it be all right with you to send this particular question and what you're looking at at techsupport@cbird.com? And definitely send your hex and all the data files that you have so that we can take a better look at it. And I don't think it'd be feasible to answer this particular question in this session. So please do send us an email.
And we will also have contact information for everyone submitting these questions. So we can potentially reach out as well if we don't hear from you. All right, it looks like we got some extra information on the question about integrating fluorometer and oxygen sensors. They're asking for what kind of wires we need and the physical location of the sensors and connections. Sounds like that might also be another email question potentially.
Yes, we can definitely send you an email with that information. I would highly encourage people to look at our application notes on the website. A lot of you can find really useful documents over there for how integration will take place now. Yeah, but I'll make sure that I send you the information via email so that you have a visual.
Thanks. Let's see. And then Abigail is asking, how do we see bubbles in the data?
Okay. Usually those bubbles in the data appear in a unidirection, like your deviation in the data will be unidirectional. I have a good documentation on that, Abigail, and I'd encourage you to again email just for a reminder, but I'm keeping notes of these questions so that I can send you those information. We have the example of how kind of see the traces of the bubbles in the data. But good question. Thank you.
Excellent. Let's see. Let's go up to Fred's question. Does SBE 19 use any kind of biofouling devices when it is being used in mooring mode?
Yes, we do use an anti-foulant and it's something you can also request when your 19 plus V2 is in service, that you would need a antifoulant in your system. Is the question more specific about what kind of antifoulant, or is the question really, is there an antifoulant? So if you could clarify, that would be helpful.
Let's see if we get additional information there. And then we got clarification on the connection between temperature and conductivity question. About temperature and conductivity tube connection, Tygon tubing with wider diameter is the one used between sensors, the Y fitting in the pump, but it is the sensor between the temperature and conductivity sensor, the tube is smaller. Does it possibly get loose easily? I think is the question. Not
in our experience, because when we send the unit back to you, we make sure all the tubings are fit and tight, and you wouldn't have to kind of tinker along with it until and unless it's absolutely necessary. So the answer to your question is no, it shouldn't be loose fit.
Okay, so it looks like we are just about at time. For those of you whose questions we didn't get to, we will reach out via email, and if you don't hear from us soon, you can also contact tech support, or you'll all be getting an email from Zoom with my email in it. So if you have any additional questions, please feel free to send them my way, and I will pass them on to Nilza and Dane. If everyone could take a minute after this session ends to fill out our survey, we would love to get your feedback and factor it in for future years of SBU. So I will, I'll let Dane and Nilza say anything if they have any final words.
Thanks for showing up and listening to us talk about this. This is something that we're always really excited to talk about and share our knowledge about. So thank you all, and I hope this is very helpful.
Yeah, absolutely. Thank you everybody for joining at 8 a.m. or if anybody is there in the earlier time zone, thank you for waking up. We've done that ourselves as students before. So thank you everybody, and I hope you have a great cup of coffee.
Thanks everyone, take care.
Bye-bye.